Hey guys, this is Kirob speaking, and today we are back into making the Countess Run Simulator, episode number 15. So far we have spent a grand total of 32.5 hours on making this program, and progress overall has been really good. But since like 2 months ago, no more work had been done because of some other things, like automation getting its big release and my YouTube channel going crazy with other kinds of videos. Was first the cycling manager, new cycling manager coming out, to which I'm now I think the biggest English-speaking pro cycling manager 2018 video maker, I guess. And of course your automation videos, which took a lot of time and has been crazy. Oh yes, and the Tour de France and so on. But now we are back. Now we are back to making and finishing off this nice little product. So fortunately, at the end of episode number 14, I told you what more things I had to do. And if we just launch this program right now, and I have my notebook here too. I took a few notes. Of course, I spent some time finding into this again. I spent about an hour looking into the code and rewatching the end of my last episode and taking notes of what needs to be done in today's episode, so that I can bridge the gap of between episode 14 and this episode. So this is where we are currently, and last time we finished off a fair big amount. Like the confidence thing here is now done, which we shall see very soon. Let's make one core rune and one child rune, bam, like this, and let's do 500 repetitions and simulate. So it kicks off, and you see the average number of runs needed in order to achieve that, and the number of repetitions clocking in down below, which is really nice, and all kinds of cubings and whatnot. Simulation time running, we're almost done, just let this run out. So this is now doing the 500 simulations with X number of runs each in order to achieve the goal, and this time, the last time, it went down in 10 runs. Very nice. So now we have the data sitting here, and I can change the mode. And the 50%, oh interesting. Yeah, the mean was quite a bit lower than the average. Very good. So if we want to be 60% certain that we get all the runes, we would have to do 38 runs. At 80% we would have to do certainty that we have those 2 runes, we would have to do 58 runs, and if we want to be 100% certain, then we have to do the highest amount of runs that we encountered during the 500 repetitions, which was 142 runs to get a core rune and a child rune. Well, that was horrid. Maybe it would have been better to just cube up more runes in that case. But anyway, so today, let me see. One thing I wrote down that that remains to be done is that, yeah, you do get the actual mean number of runs. So the letters do have to change for this. But also what we want to do is to give you a proper time estimate for what you have set in the confidence mean mode. And so right now only one number changes up there. And what I want to happen is that all the numbers, apart from sim time obviously, do change with what you set here, depending on what you choose. Like, yeah, okay, 20%, then probably you didn't do any cubing, so the average total time should be reflected, like 14 runs worth of time. So you see, like, okay, how long do the 14 runs take? And let's say we had to do 1 cubing. So what is that for this setting? What is the actual total amount of time we need? And I thought about this a little bit. So what I think we need is to go from a DS list construct to a DS grid construct, so that I can save the number of cubings that were done, as well as the number of runs. And I think we have that here somewhere. No, this is the create thing, so it should be in the step. Yes, here, right. So right now we are making this list where we, this is the list name, run numbers. And then we just input the runs completed into this list for each of the repetitions. And I think what we need to do is to input the number of cubings as well, and use that. And then for the same number of runs, once we are done, for the same number of runs, we go through this list, this big list, with 2 columns, so it's a grid, with 2 columns, and add up all the same run numbers, add up for them, or average rather, and the cubings numbers, and that will give us the average time and cube time for that set of number of runs. I hope that is somewhat clear. So when you set the mean to something like 40% and it shows 25 runs, how many cubings have you done by doing 25 runs on average to get to your goal? That is what I want to output. And all the other values are dependent on that. So the only thing we really need to add is the number of cube actions in there. And that should give us, via some quick calculations, the other times in here. All right, let me get started with that. Okay, maybe this is working like this. We have made a grid, which is called run numbers still. That was in create, right? Run numbers, DS grid create. And we have, that's the width. So column 0 and 1. And then the object settings, number of repetitions, is the length of, or the height of this grid. I think that makes sense. So now we go to the step. And in our state of we found all runes, we then set this grid, that's the ID. Yes, you have to mention that first. Then X and Y. X value, 0, so first column. Then repetitions completed. Oh, repetitions completed? Do we have to -1 that? Yeah, we do, I believe. Otherwise it runs off the end. Yes. Alright, but yes, anyway. So this is our Y value, and then we put the runs completed, so basically how many runs you needed, into that field, into that data field. That's the value to be stored. And we do the same thing, but with the X value of 1, so column 1 instead of 0, for the cubings completed. That should save all the data. Now I just need to make sure that it doesn't run off the list there. Now with the grid, we also do need to check like the mean value, as we did with the list before. And it's just ever so slightly more complex with this grid instead of the list we used before. List size is basically the height of the grid, and then we have the mean number of runs, which is within the grid, the number of runs it has at the index, the Y value of this one, list size, and then I believe there needs to be a -1. Isn't that right? No, I think it's just a floor, but it might still be a seal, like taking the rounded up value instead of the rounded down value. Let's see if this works. This is certainly a point of contention. My little brain can't really cope with this right now. should be simple. So if you only have one entry, then the list or the grid height is 1. But that means it is at index 0. The y value of that element would be 0. So that means x0, y0 needs to be red. And that only is workable if we take the floored value of 0.5 times the list size, which in that case would be 1, so 0.5, floor that would be 0. Okay, I think that's how it needs to be. Alright, I worked my way through the stepping function, and I think I have adjusted... all but this one. While I'm saying it, all but this one. There's list empty. Is there an equivalent function for the grid? I think other than this one, I have switched over everything from a list to a grid. So very soon I'll be able to see how badly it crashes once I try it out. Okay, ready to run? Let's see if it works in some way. And there we go. So far, no crashes. That's decent result so far. And we want to find one tile rune, and in normal difficulty. And let's go. And see. Oh, okay. It does something. It did something. Average runs 2. This is working straight out of the box. What the hell is going on? Oh, okay, not quite. Average number of runs? 0% sure. Well, yeah, you can be 100% sure that 0 runs won't be enough. So that's not quite right. But yeah, the 0 probably shouldn't even exist as a concept, should it? But it should show you the minimum number of runs you ever needed. Basically the quickest that ever occurred. Well, I have to look into that. That looks like an indexing problem for the grid. But this is still working, so overall I think this is good. This is good to go. We're good to go to add some cube time into it. To better understand what's actually going on there, what it is looking like, let me quickly output one of those arrays, which we are getting. I don't need many repetitions, just 50, yeah, that should be fine. One room that cannot be found, and simulate. Let's see what it looks like. Oh, out of bounds writing. Oh, interesting. Interesting. Why is it out of bounds writing? So it doesn't even get there. Interesting. Good. That's a flaw. That's not supposed to happen. I think that was the issue. There was a -1 here from the start, which would mean that before, like you see that, this variable is actually incremented after we're reading it. So that means there is no need for -1 because it starts at 0. Alright, after supposed bug fixes, let's try another thing. And we're cubing everything so that we have some data there, actually. And also I'm using normal difficulty instead of hell, where I could find a full rune in the first run. So here we go. Let's see if that works. So far, so good. Oh, undefined. Everything's undefined. Everything is dead. Oh my god. Stop it. Okay, there we go. Finally. Finally, what we needed. We have a little list down here with the number of repeats as the first one, then the number of runs needed, and the number of cubings to get there. This is one full rune in normal difficulty. Okay, let's see. So the data is looking good. There are no zeros in here, nothing weird. They all look like proper data. Yeah, so this is what to expect, basically. Alright, so with this, we can work. And yes, we have fixed the bug. We have also fixed the bug that when you set it to 0 here, it showed 0. That's no longer the case. So it seems like our data structures are now somewhat more reasonable and actually functioning. And there we have our lonely event. 4 runs needed with 1 cubing. So now let's just quickly find out how many runs we actually need to get 1 Zod rune in normal difficulty. Seems simple enough, right? Yeah, let's hammer it. And the run number, sure. Oh wow, we wouldn't be able to see that now. We wouldn't be able to live that day once this is just up to a co-rune after a lot of runs, 230,000 runs. Well, that would take too long, so abort. But alright, now we know that we have the correct data in there, and that the simulation works, the mean stuff works, it's all good. Now we need to do calculations with that data that comes out. And I want to do the averages of equal run numbers. So now I have to think about how to best do that. Okay. Hear me out. So, how many different results can there be for number of runs needed? There can only be the number of repetitions as the different number of runs needed. So if we make a list, with the unique numbers of runs needed, then that list needs to be the same size as the number of repetitions to cover all cases. Okay, so far so good. So if we are indexing them by going through the grid and having that one sorted, and then filling a list by going through this grid and adding and averaging all the run numbers. Is this too complicated? Maybe it is. Let me have a little think here of how to best do this. There must be a better way. My god, this took so long. Oh, my brain is kind of fried. I don't know why. Probably because I haven't been programming since last episode. And this was a little tricky. Problem is that these grids only accept integer values. Now that's a limitation. So I can't be doing any kind of arithmetic stuff in them. Oh wow, words. You see, my brain is actually fried. So, no floats inside of them, and that means that I somehow need to work around that. So what I'm doing now, hopefully, is that I'm going through the big list of entries, which looks like this, sorted. As you see here, these are sorted. This list up here is unsorted. So we take the sorted list of number of runs, number of cubings, and then what I'm doing here, or attempting to do, I think this should be working, is that I check if this number already is the current number of runs. If it is, then we add the number of cubings to the current number and increment the number of repetitions in that bucket by 1. And so we step through all these data entries and add to the number of cubings, and then later on we can just multiply the number of cubings with the time it takes per cubing and then divide by the number of entries in that bucket, number of repetitions in that bucket. And that should give us the average with a decimal place or decimal places of time it takes. So that's good, but it took way too long. So anyway, this is the code. This is the code. As you can see, my brain is fried, so I need to comment it really nicely so that I understand it myself. Working with these grids is not entirely straightforward, it seems. So wait a second. I've commented out these message logs. Okay, that's fine. We make 2 new variables, the looper variable and the cube numbers index. And the cube number is the cucumber of our new grid. There we have it. Save this. Cube number is a grid with 3 columns and the number of repetitions, because as we said before, the number of repetitions will be the maximum number of elements in that array, or rather grid as it's called here. So let's head back here and see if that is working. But how do we see if this is actually working? Probably by outputting the sorted list like this, and then later outputting the final array we've made for this new thing, the cubings. So let me implement that real quick. Alright, I think I figured it out. There were quite a few bugs in here, especially my switching around of X and Y coordinate in those grids. Oh my god. Brain fried. But now, let's take a quick look. This should indeed be fixed now and give us the data we need. And that's just a small step along the way. Look at how much time has been lost just for this stuff. Well, we mark all of it, all the cubing, normal difficulty. 50 repetitions, and we want to have 1 full rune. And everything set up? Yep, simulate. Alright, so now it's running. It's running, and there we go. So let's have a quick look down here. These zeros are expected. Oh, these ones are not expected. And these writing out of bounds are not expected either. That is not good. But at least one thing we're seeing here is that all the numbers are represented. All the run numbers are represented. So that would mean... is the lowest 10? Yeah, okay, so that is working. Good. So now just the second part of my loop seems to be fucking it up. The else. Let's take a look at that. Looks like it just was another issue with XY switcheroo. Okay, so that should fix it. Let's run it again. Yes. Look at that beautiful stuff. So this is the sorted array, and let's check. We have, for instance, 1, 2, 3, 4, 5, 6 15s in there. 6 15s. 15s, 6. 69. 69 in total. Let's see if that is 69 in total. So that is 32. 40 for 55, and then a 55? Really? No, 54. Good. 54, because we had 110 there. And then plus 15. Yeah, that's 69. Okay. It's working. That is working. And so now we've written a simple algorithm which just stacks the values for duplicates. That did take way too much time for how simple it actually is. But yeah, that's the danger of letting projects just lie around and not actually programming something else in the meantime, because your brain just gets mushy. Okay, but now we do have all the data we need, and now we can go in there and try to find the first value for whatever mean we have determined, and for that we will get the number of runs. Oh, no, the number of cubings. And we can divide the number of cubings, or rather the time that is resulting from this number of cubings, by the number of repetitions that had that number of runs. Okay, I think we are there. So let's try something bigger here as well. Let's try something big so that we see that it actually does not collapse. Okay, yeah. How about a low rune in hell? Oh wow, that's taking a while. And that is at 100 runs a frame. Well, if it can keep up. Probably not. I should have put it to lower repetition numbers. Let's repeat that. Okay, that's a better setup. That's a much better setup. Let's see, on average it takes something around 1,700 runs to get a low rune. And... did it crash? No, it's just done. Very good. So, mean is 1,711. And if you get unlucky, it takes 2,350 runs. And if you get really, really lucky, then it takes 745 runs if you have 100 repetitions. Okay, so far so good. That's all looking decent. Let's take a look at our data. There really should only be ones here. 1, 1, 1, 1, 1. Yeah, there is. Excellent, because there are no duplicate values. So that means with the size of the grids, we've done everything right. I wanted to have this very special test case of everything is in its own bucket, and that seems to be working. So that is what we need. Cool. So that's tested and functional. Alright, let's take a quick look if the first thing is working. Yeah, that is working. Now I just need to find where the hell I'm calculating these times. That would be interesting. So, text switching was easy enough. Okay, I think I figured it out. So, what we need to do here, well, what we already have is the mean number of runs at the current confidence setting. And what we are going to do with this is to find the grid index in our cube numbers grid and try to find the corresponding index for that mean runs value. And we know, after the stuff we've done up there, that there's only one in there that is equal to that number. So what we're going to do is search the list of in the first column, which is the number of runs needed in that grid, and go through it all and try to find the mean runs in there from 0 up to a list size -1. That is the index, the maximum index you can go up to. Then I'm now having a few... oh shit. These are from the data manager. I need to address them correctly. That is an oversight on my part. Yep, okay, that's bad. Anyway, so just ignore that for a sec. So then I can calculate the runtime by mean number of runs times the runtime that was set in the settings. I can calculate the number of cubings, or rather not calculate that number of... Oh, no, I have to calculate it. By the number of cubings by reading out that value from my grid and dividing it by the number of repetitions that had that value, because this is the sum that had the number of runs. So this is the sum of all cubings that were done in all repetitions that had that number of runs. So I need to divide by the number of repetitions. And I need to do this so convolutedly because these grids only accept integers. Yes, that was the reason why. Then I can calculate the cube time simply by multiplying with the cube time. And then I get the total time by adding the cube time and the runtime. And that's it. That's it. That should then be the mean runtime with the average cube time for that number of runs. Oof, okay. So now let me just add the objects in front of here. That's from the data manager. And with the layout I chose in the data manager, that's why I put it in there in the first place, like this. And now I can do this. I now have an if-else in here, depending on which confidence mode we're in. And now I can use my new calculated values instead of the old ones when it is appropriate. And let's see if that is working. That was, again, quite a bit of coding and no testing. Let's see if it all explodes. Okay, everything is cubing, and we want a full run once again. We've done so before. Let's see, come on, first try. Please work. Okay, it didn't explode. That's good. Mean? Oh no, it's all zeros. That's not good. I don't like all zeros. It's mean. Ha 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 ha. Please shoot me. Oh, and now it just kills itself. Oh, there's something really wrong. It was just the usual killrod being a 4. I forgot again adding the object data manager dot in front of it. So it was trying to read variables which didn't exist. Brilliant. But now, one more try. Again, 50 repetitions, a full run and normal with all the cubings. And there, it's that 0. Now, what am I doing? Oh, now something appeared. Oh, and they're changing. Oh, that's good. So something's going on. Something is working. So the only thing that isn't working is when you're coming in. When you're first getting there. I think I know what it is. Yeah. I think that is missing currently. Yep, that is. This is the default value you see when you get in there before you've pressed any other buttons. So that one needs to be switched out with this. And that should be it. Okay. Yeah, I think this should be done now. Okay. 500 repetitions, 45 seconds per run, and 20 seconds to cube. Need to cube everything. Well, okay, no, let's not cube everything. Let's just cube tal and ral and ot. Yeah, that's good enough. That should be good enough. And 100 runs per frame, yeah, and normal, yeah, it's all good. So, let's go. Yes, adequately fast. That should give us quite a few data points in each bucket. That's good. And there we go. It's all done. And now, if we switch mode, yes! Yes, it switches everything. Okay, let's have a look. So, if you want to be 50% confident, then we have an average total time of 1032 seconds. 55%, still the same, still 20. And okay, 21, 22, 23, 24, 5, 7, 9, 47. 47 was the worst. Okay, average number of cubings. Well, that was the... Oh, we could even do something like if there's only one data point, then the average is being removed from the string. Is this a little too much to ask for? It's still correct. I mean, it's still the average. It's just one data point. So I think I say fuck you to that. Yeah, fuck you, Carol. That is a stupid idea. Okay, but I'm quite happy with the data we have here now. So now it is time to think about some of the other things. I did list some other things I wanted to do today. Let me have a quick look and see what more we can do today in this episode. Alright, this was an easy win. Ticked off the list. I reformatted these values up here to only have... Oh, average runtime probably should also not have a decimal. But, oh, well, it depends. That depends. No, probably not. That's too much. But average cube time and average number of cubings is an integer, so it shouldn't. But as you can... Oh, wow. Oh, what is going on here? This is behaving weirdly. This is... all fucked. How did we even get there? Oh, interesting. Okay, there's a bug in the button logic here, which I need to fix as well. But yeah, that's an easy win to actually format the numbers correctly so that they are not all over the place with showing all the decimals and confusing people. I think I might have found it. So the big selector for the confidence mode, if it's like average or mean, only the plus or only the minus side did have all that logic. The plus side never actually set anything. It just did its bare bones logic for activating the buttons, but never set values properly. So I believe that might be the bug. It certainly would fit the description. Let's see if it still works. Yeah. Oh, no, damn it. You see that? 75, but still can't go down. Does it work here? No, also not. Ah, damn it. So the bug is not fixed by that little thing. I think I found it. It was the difference between if and else if. If you have an else if here, then of course it only goes in there if this one failed. And, well, that would lock the button, the plus button. So that seems to be the issue. Let's run it and see if we fix that. Yes, now it is fixed. Because it would only be an issue once you do this twice. Once you cycle twice, and then it will be locked. So this is looking really good. Yes, everything's working. Average number of cubings does need a decimal place. And the last thing I would like to do today is try to add some like sound effects for a bit of atmosphere, some background music. The crypt music, for instance. Let me have a go at that.
Here for a bloodbath?
Okay, I think I'm done with the audio. That was pretty quick for it being audio and scary. But yes, so I do have the Countess taunts in here now. They are here.
Here for a bloodbath.
Oh, yes, yes, exactly. And this one as well.
Blood will boil.
And what I'm doing with this is, let's see, in the results, if the countdown timer, did I do it here? No, did do it here, yes. So if the countdown timer hits a certain value, where we are doing the sim start time counter thingy, then I also start playing the Countess taunt, but I randomize it. I get an integer random between 0 and 1, and if it's 1, then I play 1, and if it's not, then I play the other. So, easy. Okay, here we go. Let's try it out. Let's try it out. Oh yeah, the sounds need to be... Oh yes. Oh, there we go. That's the crypt, alright. This is working. And now let's see if we want to just do a number of runs. Whatever. And press simulate.
Here for a bloodbath.
Yeah, that worked, but not quite. It triggered at the end of the countdown. I wanted to trigger at the start of the countdown. And now the only thing missing is the exit button, I believe. And that one also needed a new sound. I have this one prepared for it. Yes, broken item. Glenn sent all these sounds over. Thanks very much to him. That saved me a bit of work to dig them out. Very kind. All the taunts and stuff. So I think that should work. Now let's search for the exit button. So now, in all its glory, let's see what we have here. Yes. It feels like Diablo. Because it is Diablo. But a little faster to run, as we have noticed. And let's go for a Talef. There we go. Talef. Stealth armor. How long do we need? We do want to have very accurate data. So we do a lot of runs. And yeah, it's about right for normal. No cubing. No, cubing is stupid. You don't have the cube in normal when you do the tower runs. So, are we ready to simulate? Yes, we are.
Here for a bloodbath.
And it starts perfectly when the Countess is done. Okay. And there we go. So, simulation done. We have all the data. The mean. 5, 6, 7. Okay. Well, that's pretty good, but we're lacking a decimal place here, which is really important. So I need to fix that. Oh no, wait. Mean run number of runs. No, average has the decimal, yeah. And that one probably needs another decimal if the value is below 10. Otherwise, that's a little inaccurate. Okay, so now we're ready to exit and... yeah, well, you can't really hear that, so I need to implement a delay, I would think, somehow. Is there such a function in here? No, unfortunately not. So I would have to trick it somehow. That's unfortunate. That is unfortunate. Alright, implemented that. If it's below 10, 2 decimals. If it's below 100, 1 decimal. And if it's not any of that, then 0 decimals. I think that should make sense. And maybe we could do something similar for the times. But that is some polishing I could do next time around. So it's getting late, as you see. It's sleepy time soon. Alright, yeah, that's working. That's working. Let's also try one that should take a long time. 1 ghoul rune, please. 1 ghoul rune, please. But 100 runs per sec, and we are just doing 1 repetition.
Your blood will boil.
And there we go. No, 95! We were lucky! We're so damn lucky! What the fuck? How did that happen? That means we found 2 Istrunes in 95 runs. No, oh, well, no, not necessarily. Probably she dropped it herself. What a damn lucky run that is. Okay, once again, please.
Your blood will boil.
And there we go, 186, still extremely lucky. But, yeah, there is no decimal on that now. And with all that done, I think we are done for today. Let's take a look. Recording time, probably 4 hours. Yeah, 4 hours. But I did take a dump in between, so that has to be counted out. Anyway, this episode was a little bit of a dump of brain farts, I would say. But still, I mean, we are almost at the end. So what will come next is I'm going to hand this version over to my patrons and have them test it out and give some feedback for easy fixes and improvements. And then next episode I shall wrap this whole thing up. It's looking good so far. So I hope you enjoyed and see you guys next time.